Now this is a paragraph based question, and paragraph for the next two questions, that is question number 12 and 13, is here. It says 2 point charges plus Q1 and minus Q2 are placed at A and B respectively. An electric line of force emerges from Q1 at angle alpha and terminates at minus Q2 at angle beta as shown in figure. The electric line of force has been shown here. It's emerging at A at angle alpha with the line AB and meets B again at angle beta with line AB. Now question 12 says if alpha is 60 degree and beta is 90 degree, then value of mod Q1 by Q2 is equal to, the solution will be based on the Gauss law, and the solution will also be based on the concept of electric flux. Point is this, that if we consider plane angle 2 alpha, so alpha on the upper side and alpha on the lower side, that means 2 alpha angle, and the solid angle subtended within, so the number of all the electric field lines which are passing through this circle that I have drawn will also pass through a similar circle, let's say like this, which means that the flux through this solid angle, we can call it omega 1, is equal to flux through this solid angle omega 2. Now our solution will be based on this concept. Phi is equal to plus Q1 by epsilon naught. This will be the total flux that emerges from point A, but we have to only look at flux through this solid angle, and this is equal to omega 1 by 4 pi. 4 pi is the total solid angle around a point. The value of omega itself is given as is equal to 2 pi into 1 minus cos alpha, and similarly this is also equal to Q2 by 4 pi epsilon naught. Omega 2 will be 2 pi into 1 minus cos beta. Let's put the values that's been given to us. So we get Q1 into 1 minus cos 60, that means Q1 into 1 by 2 equals Q2, which means Q1 by Q2 equals 2. And which means option A is correct. We can now go to the next question. Question 13 says if Q2 is equal to Q1 by 3, then maximum value of angle alpha at which a line emerging from Q1 terminates on minus Q2 is. Well, the maximum value of angle beta can be 180 degree, and corresponding to angle beta 180 degree, we have to find the angle alpha. So that being the case, our equation is now Q1 into 1 minus cos alpha max is equal to Q2 into 1 minus cos 180 degree, and which means Q1 into 1 minus cos alpha max is equal to Q2, which is Q1 by 3 into 2. Solving, we get 3 minus 3 cos alpha max is equal to 2, or cos alpha max is equal to 1 by 3. So that alpha max is cos inverse 1 by 3. Well, options A, B and D do not match. So what we do is we draw a right angle triangle whose base is 1 and hypotenuse is 3. The perpendicular is under root 3 square minus 1 or under root 8 or 2 root 2, and here is your alpha max. So we can see that tan alpha max is equal to 2 root 2 or alpha max is equal to tan inverse 2 root 2, which is matching with option C. So option C is correct. Let's go to the next question now. Well, we now have the paragraph for questions 14 and 15. Let's read the paragraph. It says, an ideal gas is taken through a thermodynamic cycle ABCDA. In state A, pressure and volume are P0 and V0 respectively. During the process AB, work done by the gas is 0 and its temperature increases twofold. During process BC, internal energy of the gas remains constant, but work done by it is WBC equal to minus P0 V0 ln 2. In the process CD, the temperature decreases by 50 degree while the volume does not change. In the process DA, the temperature of gas does not change. Question 14 says, which of the following graphs correctly represents the cyclic process? And among the options we have two graphs of pressure versus volume, options A and B, whereas options C and D are in terms of pressure versus density. So let's evaluate the options. Let's draw the process on a PV graph. So we have these two axes, pressure and volume. It's given that process AB is isochoric process because the work done is 0 and the temperature increases twofold. So let's say this is point A, and at point A, so here the coordinates are V0, comma P0, and process AB is isochoric process in which the temperature increases twofold. So that means pressure also increases twofold. So from A to B, here we again have V0, comma 2P0. Then in process BC, internal energy remains constant. That means it's a isothermal process and work done is negative, so it's isothermal compression, which means volume is decreasing and pressure is increasing, and it will be a rectangular hyperbola, so it will be like this. So let's say this is point C, and from point C to D the temperature decreases and the volume does not change. So volume remains constant and temperature decreases, that means pressure also is decreasing, something like this. And from D to A, the process is isothermal again, so it is something like this. So if we look at the options, neither A nor B matches with this. Let's now look at the variation of pressure with density, and for doing that, let's take help of the equation of state PV equal to nRT. We have to introduce density here. We know density is mass by volume, so volume can be written as m by rho. So that means we have P into m by rho is equal to nRT, or so we have P is equal to nRT rho by m. This expression we can use to draw P rho graph. So for the process AB, volume is constant. If volume is constant, so density will also be constant, and pressure is increasing, so density will also increase. So if I draw a graph, pressure versus density, so let's say we start from A here. The density is not changing, pressure is increasing, so it will go something like this. Let's say we come to point B. From point B to C, it's isothermal compression, which means we have the graph P versus rho graph will be a straight line graph in which the pressure is increasing. So from B to C it may be something like this, and when extrapolated it will pass through the origin. What about CD then? CD is again isochoric process in which pressure is decreasing. So we have CD again a vertical line, something like this. And DA is again an isothermal process. So when this will be a straight line, and when extrapolated it will pass through the origin. So if we look at option C and D, we can see that this is matching with option C and not with option D. So option C is correct. We can now go to the next question. Question 15 says total work done by the gas in the cyclic process is, we have been given the 4 options. Well, to calculate the work done in the cyclic process, we go back to the PV graph. Let's draw the PV graph for the cycle again. We had point A here, and let's say here volume is V0, pressure is P0, temperature is T0, and then from A we go to B. The temperature has become double. It's isochoric process, so here we have V0, pressure has become doubled, and so has the temperature. B to C is isothermal compression, so we know the temperature here is also 2T0, and other things we don't yet have. C to D is again isochoric process, and from D to A is again isothermal expansion at temperature T0. Now work done in the cycle will be there only in 2 steps, that is step BC and step DA. So work done in BC, by using the formula for work done in isothermal process, is NR, temperature which is 2T0, ln Vc divided by V0 or Vb, which we know is equal to V0, and this value is given to us as minus P0 V0 ln 2. Now P0 V0 is NR T0, so P0 V0 is NR T0, so that means we have this is equal to 2 P0 V0 ln Vc by Vb, and as per the question this is equal to minus P0 V0 ln 2. That means 2 ln Vc by Vb is equal to ln 1 by 2. Work done in process DA is equal to NR T0 ln Va by Vd. This is same as NR T0 ln Vb by Vc and we can see here that ln Vc by Vb is equal to 1 by 2 ln 1 by 2, and this will be equal to NR T0 1 by 2 ln 2. Now NR T0 is P0 V0, so this is equal to P0 V0 by 2 ln 2, and so the total work done in the cycle equals WBC plus WDA, and that is equal to minus P0 V0 by 2 ln 2. Let us look at the options. option D is matching. So option D is correct. Let us now go to the next question.